Assalamualaikum and good morning, everyone. Hello, dengar tak?
Dengar.
Morning, sir.
Okay, so today we will go into our first lecture on. We will review on some of the mathematical concept before we can start understand about continuum mechanics. Okay, so first topic about mathematics that we are going to cover is about vector. So at the end of this lecture, you will be able to understand the basic concept of vector and then perform mathematical operations on vectors using index notation. So in vector or in programming, usually we have um, variables that is defined in the form of arrays. Okay, so actually for example in MATLAB, the array can be equivalent to can be made equivalent to uh, a vector. Okay, so firstly, a scalar or a constant is basically a zero order tensor or tensor. Later on in next week lecture, we will see more about tensor. So tensor is basically a matrix. Okay, to a layman term is a matrix. So a scalar basically a single number or a one by one matrix, or we call it a zero order tensor. So a vector is a long array, okay? A one by um, row by column. So row can be any number, but column is usually one. Okay? So a vector is a first order tensor or n by one matrix. Okay? So a vector uh, is usually used to represent a physical quantity, for example, like force, acceleration. So this physical quantity has both direction and also magnitude. So vector has direction and magnitude. So example of vectors in mathematical notation that you commonly use is, for example, like 2D vector. We can write A equals A1I plus A2J. So I basically the vector in the x direction, and J is the vector in the y direction. So for a 3D vector, we have the K component. So
Doktor,
A1I.
doktor ada
Mm-mm.
share screen tak?
Tak share. Saya dah share.
Uh,
Alamak. Alah, patutlah
Macam
tak
tak
cakap.
nampak.
Saya suruh tak cakap. Sengit. Patut saya dah share tapi tak keluar kot. Okay, sorry. Okay, boleh nampak screen.
Nampak.
Okay, so tadi tadi slide tadi just introduction, so not really important. Okay. Okay, so we have 2D vector a1i plus a2j. So I is the vector in the x direction and j is the vector in the y direction. So for a 3D vector, we have the z direction. So we represent with k symbol. So usually vector we write in a small letter, okay, lowercase letter, and if in writings dalam Word document, for example, we can bold this vector. But in handwriting, kita tak boleh bold lah, takkan nak tulis guna pen tebal kan. So the IJK represent the basis or the unit vector. So later on, we will use the term basis. Okay, so basis or the unit vector for the Cartesian coordinate system. So we have I in the x direction, j in the y direction, and k in the z direction. So basis means the unit vector in in a direction. Okay? Unit vector maksudnya vector tu ada magnitude equals 1. Okay? So basis means unit vector means magnitude equals 1 for a vector. Okay, so this is the same thing, but we use IJK usually during high school, masa sekolah menengah, in form 4, form 5. But in most textbook, they use the E1, E2, and E3 symbol to represent I, J, and K. So this is to avoid later, maybe if we have 4-dimension vector, for example, then you need to add I, J, K, L. So if you have more dimension, then jadi banyaklah I, J, K, L, M, N, O, P, Q. So it becomes not convenient. So they use symbol E instead. So they name it E1, E2, E3, and so on. So we can write a vector as a linear combination. So A equals A1, E1 plus A2, E2 plus A3, E3. So A1, A2, A3 represent the scalar or the coefficient of the vector in the basis E1, E2, A3. So we can find the magnitude using this symbol, palang tegak. And then the magnitude equals square root of each of the scalar squared. Okay, A1 squared, A2 squared, A3 squared, then square root. Okay, so benda ni dah pernah belajar dulu. So after we find magnitude, we can find the unit vector in the direction of another vector. So for example, if we have vector A, then we can find the unit vector parallel or in the direction of A using this formula. So A, the vector A divided by its magnitude. So this unit vector captures the direction information contained within the vector, but remove or discard the magnitude. So sometimes kita nak tahu, we want to know the direction of a vector, but we don't want to know the magnitude. Okay, so we can find the unit vector. Okay, so let's say if two vectors are parallel, let's say A and B are parallel. Parallel maksudnya selari. So one vector can be written as a scalar. Okay, scalar means macam berkali to the other vector. So A, let's say A equals alpha B. So meaning that A is parallel with B, tetapi dia punya scale is alpha. Okay, dia punya magnitude is different. Okay, so in most textbook they use index notation. Okay, so I think you never encountered index notation before. So sometimes it can be complicated to write equations or perform operation involving vectors and tensor. So a vector A can be written in a more compact form using index notation. So just now A equals A1 E1 plus A2 E2 plus A3 E3. So we can write this as a summation of from I equals 1 until 3 AI times EI. Okay, so this means that dia tambahkan je A1 E1 A2 E2 A3 E3. Okay, so this summation means repeat the index I from 1 to 3. So this actually reduce the length of the writing. Okay, so we call this Einstein notation. So instead of using the summation, we can just write A equals AI EI. Okay, so don't worry about this. So Sam ni saya tak tanya soalan berkaitan index notation sebab dia menyakitkan kepala. But maybe later in subsequent lectures, maybe we might encounter some mathematics that involve this kind of notation. So I teach you now so that you tak terkejut lah. So vector can be added. Okay, like last week, uh, I asked you a simple question about vector, so you know that the vector can be added. Okay, so the sum of two vectors, let's say b and c, is equal to another vector. So a equals b plus c. So dia ciri-ciri summation ni or the addition is commutative. Okay, so this is not really important lah. Like not gonna ask you what is commutative. Okay, so basically b plus c also equals c plus b. So dia tak kisah urutan mana nak tambah. So the components of the vector b and c parallel to the same basis vector can be added. Okay, so kalau B dan C dia punya basis vector dia yang tadi E1, E2, E3 are in the same direction, then you can add. Okay, so if E1, E2, E3 are not in the same direction, so you cannot add the vector. Okay, so for example, so B1 plus C1, E1, because they are in the same direction, so you can add B1 plus C1. So E2, B2 plus C2. So it's the same thing, but now the symbol is E. So last time you learned it in the symbol IJK. Okay, so this gives three separate equation. Okay, so we have A1 equals B1 plus C1, A2 equals B2 plus C2, and A3 equals B3 plus C3. So we can write this in a more compact notation using index notation just now, by writing it AI equals BI plus CI. Okay, so basically to add two vectors, you just add the coefficient in the same direction only. Okay, so janganlah tambah B1 plus B3 atau B1 plus C3. Tu bolehlah drop engineering. Okay, so some rules about addition of vectors. So let's say A, B, and C are vectors. So commutative or commutative tadi, A plus B is also equals B plus A. So associative means you tak kisah nak tambah mana dulu, A plus B or B plus C. If you have A plus B plus C, okay, so you don't really care about the order ataupun urutan dia. So there is a zero vector. So if you add A plus a zero vector, you get an A. So ada zero vector. So you also have a negative vector. So if A plus negative A, so you get 0. Okay, maksudnya negative A ni has the same magnitude, but direction dia opposite. Okay, so if you add two vectors, one vector going forward and the other going backward, but same magnitude, then you get 0. Okay. Okay, so let's do some exercise. So we have vector A, B, C, D. If you have pen and paper, you can jot down in your paper. So can you draw the vector A plus B in your paper? Okay, so from last week we learned about vector that let's say we have point A, B, and C. So this is vector A, B. So we can find vector AC just by adding A plus B. Okay, so you can for example, draw the first one, A plus B. Okay, so this is vector A. So vector B is 3 by 1. So you can add A. So this is A, and then just add B here. So A plus B is this vector. Okay. So kalau soalan drawing macam ni, bolehlah buat. Tak adalah soalan ni keluar. Okay. So let's say we try question number 4, C plus D. So we have D here, and then we just draw C here. So C plus D is this vector. And then let's try B plus C, number 6. So we have B and then C. So B plus C is this. Okay, so tak ada yang negatif. So let's try some negative. Let's say C minus D. Okay, so we have C. So D is going downward like this. So we want it to be negative D. Okay, so negative D, it's this direction. Okay. So C minus D is this vector. Okay, any question so far before we move on? Okay, so let's look at the multiplication of vectors. Okay, so we know that vectors can be added, but vectors also can be multiplied with each other. So let's say if we have a scalar alpha and beta and vector u and v. So alpha u produce a new vector in the same direction, but with magnitude scaled to alpha. Okay. So alpha, if we have alpha, beta, u, so you can play around with the alpha and betas, but they're scalar, they're just a number. So you can factorize alpha or factorize beta. So if we have alpha plus beta times u, so you can split them. So alpha u plus beta u. So if you have alpha times u plus v, so you can multiply to each of this vector, alpha u plus alpha v. Okay, so this is multiplication with scalar. So we also have dot product. Okay, so vector we call it vector dot product or scalar product or inner product. So let's say if you have two vectors u and v that make an angle theta. So one vector going another way and the other vectors going the other way, and then they make an angle theta between each other. For example, in this figure, so the scalar product between u and v is this formula, u dot v equals magnitude of u times magnitude v times cosine of that angle theta. Okay, so kalau kita ada theta yang besar dari 90 darjah, so if we have theta bigger than 90 degree, then the multiplication, the scalar product of u and v will be negative. So if we have theta equals 90 degree, then the scalar product is 0. Yes, because cosine 90 degree 0. Okay, good. And then we have angle less than 90 degree, then the scalar product between u and v is a positive. Okay, so this is some rules for scalar product. So if you have u dot v, it's also equals v dot u. So if you have u dot a 0, so you get 0. So u dot, let's say a vector alpha v plus beta w. So you can dot to each of this vector. Okay, macam boleh kembangkan. Okay, and then some other rules. So kalau u dot u, dia dot dengan diri sendiri, you get 0. Bukan. Okay, so kita abaikan bawah ni. Okay, so ada example tak? Lepas ni buat example. Okay, so kita tengok some theory. Okay, so we have another term, new terms to you. We call it Chronicle delta. So what is Chronicle delta? So let's say we have a vector E1 or I lah. Okay, so this is I dot with J. So we know that let's say this is X direction and this is Y direction. So vector I is always in the X direction and vector J is in the Y direction. So they are 90 degree to each other. So we have E1 dot E2 or E1 dot E3 or E2 dot E3 equals 0 because they are 90 degree to each other. Okay, so when you encounter E1 dot E2, you get 0 and so on. Okay, so when you encounter E1 dot E1 or I dot I itself or E2 dot E2 or E3 dot E3, so you get 1. Okay, because the angle is 0. So we can write this in a more compact form or convenient form, we call it. So let's say we have EI dot EJ. So we can write this in this symbol. So this symbol, we call this Chronicle delta. So delta IJ equals 1 if I equals J and delta IJ equals 0 if I does not equal J. So when I equals J, for example, like this one, if I equals 1 and J also equals 1, then you get delta Ij equals 1. But if I equals 1 and J equals something else, does not equals I, so you get 0. Okay. So later, maybe you will encounter this symbol. So just remember that this symbol equals 1 when I equals J, equals 0 when I does not equals J. But I think tak banyak lah, okay. Okay, so some useful properties of delta Ij, the Chronicle delta. So let's say if we have delta II, so delta II equals 3 because we have delta 11 plus delta 22 plus delta 33. Okay, so for a 3D vector lah. Okay, so this one, delta 11 you get equals 1, delta 22 also 1, delta 33 also 1. So you get equals 3. Okay, and then if you have delta Ij times Ui, so you can write this in terms of U. So just write it Uj. So if we have a similar symbol here, delta Ij and Ui, so you can just write Uj. So let's say U delta, let's say Jk, for example, times Uj. So you can just write Uk. Later on, we will see this more, okay? Maybe next week, okay? Yang ni pun dia menyakitkan kepala. So that's why saya tak keluarkan dalam exam. So if we have delta Ij times delta Jk, so kalau simbol J ni Satu kat ujung, satu dekat depan. So you can just write delta IK. So don't worry, tak keluar exam. Okay, so the Chronicle delta replaces the index on UI during a multiplication. Okay, so let's say if you want to find U, vector U, scalar with EJ, so you can write U in terms of index notation, UI, EI, dot EJ, and then you can expand this, UI equals EI dot EJ. So we know from just now that EI dot EJ equals Chronicle delta IJ. So you get this UI delta IJ. So this is from the properties, because this is similar. So you can just write UJ. Okay, macam apa benda lah ni. Okay, this is useful when you want to calculate something that is very long, ataupun when you have equation that is so many symbols. Okay, tapi tak ada lah, tak ditanya. So dot product between two vectors can also be written in index notation. So u dot v. So firstly you can write u in the form of index ui ei, and then v also in index form. So kita dah guna I, kita tak boleh guna I lagi. So kita guna simbol lain pula, VJ, EJ. So you can factorize, because UI and VJ are now scalar. So we get EI dot EJ. So this is Chronicle delta IJ. So it becomes UI VJ delta IJ. Okay, so this is similar, J, or you can take this also, UI and I. So if you take UI, then you can write UJ times VJ. So if you take J, then you can write UI times VI. It's the same thing. Later I will explain more, okay? So VJ, UJ, VJ, or UI, VI. In component form, you can write U1 times V1, U2 times V2, plus U3 times V3. Okay, so if you use index notation, so let's look at an exercise number 2. So given two vectors A plus B, A and B, so using index notation, prove that the dot product is the dot product between A dot B equals A1 B1 plus A2 B2 plus A3 B3. So this is actually the same thing as this slide, okay? So you can write A dot B equals AI EI dot dot BJ EJ. So we can factorize A and B. So AI BJ, because AI and BJ are now constant. Okay? So vector now represented by EI and EJ. So this is the Chronicle delta. So you get AI BJ Chronicle delta. So you can take I. So if you take I, you can write AJ BJ. Okay. Or if you take J, you can write in AI BI. Okay. But in the end, it's the same thing, because J and J are the same symbol. So if you want to write in component form, in number form, so you can write A1 B1 plus A2 B2 plus A3 B3. So kita dah proofkan lah kat sini. Okay, so another question, given two vectors, vector U, the first vector is 2, 2, -1, 2, 2, -1, and the other one is -1, 2, 2. So find the dot product between this vector. So let's find the dot product. So the dot product, let's say we name it, this is A and B. So A equals 2, 2, -1, and B equals -1, 2, 2. So for dot product, we know from these results, you just multiply the components of the vector. So A1 multiplied by B1, A2 by B2, A3 by B3. So the dot product becomes 2 times -1 plus 2 times 2 plus -1 times 2. Okay, so you just multiply the component. Okay, so instead of using the cosine formula, you can also get the dot product by multiplying the components of the vectors. Okay, so from here we get -2 plus 4 minus 2. So we get 0. So the next question says, what can you imply regarding the relationship between the two vectors based on the dot product? Okay, so what we get from this results? Anybody? Okay, so we know that when the dot product equals 0, then the two vectors are in 90 degree with each other. Okay, from previous slides lah. So we get the dot product equals 0. So we can say that A and B are 90 degree with each other. Or we can say that A and B are parallel. Okay? Not parallel, perpendicular, sorry. Perpendicular. Yes, so perpendicular means 90 degree to each other. Okay, any question before we move? Okay, so another question, exercise 3. So given vectors A equals -4, 1, and 0, and B 1, 2, and 0. So find the components of B parallel to A. So maybe you can draw this secara dummy lah. Okay, so let's say we have vector A. So let's say this is I direction and J direction. So vector A is somewhere here, and then vector B maybe here. So we can split the components of B so that one maybe in parallel with B with A, and then another one perpendicular with A. Macam nampak ni? Okay, sorry saya lupa.
Saya tak faham.
Kak mana tak faham? Tak apa, okey
Dari
je.
awal.
Bingung. Dot product ni faham kan? Ke tak faham?
Soalan ni.
Soalan nombor 3 ke?
Ya.
Okay, so sebenarnya nombor 3 ni dia tanya pecahkan vektor B. Pecahkan vektor B supaya cari komponen B yang parallel kepada A. So let's say if we have two vectors, let's say one vector A and then one vector B. So we can always cari B yang parallel kepada A. So we name it BA. Okay. Maksudnya projectkan B kepada A. Macam mana nak tunjuk? Let's say if we have vector I here in X direction, and then another one is in J direction. So let's say we have vector B kat sini, B1I plus B2J. So B1 ni dia adalah parallel in I direction, while B2 is parallel in J direction. So similar concept lah, tapi now maybe vector A tu saya ingat sikit, and then vector B let's say menegak ke, for example. So we can find the component of B parallel to A, and then another one yang perpendicular to A. Tu je maksud dia. So actually we can use dot product, tapi lupa macam nak buat. Ya, padam dulu, semak banyak sangat. So I think you can do this by first draw. So let's say A, and then vector B. So we want to find B yang parallel to A. So B parallel to A. So we want to find this vector. Okay, so to find that vector, so you can first find the dot product. Okay, so if you find the dot product, basically you will find this magnitude. Okay, so dot product you get -4 times 1 plus 1 times 2 and plus 0. So you get -2. Okay, so the magnitude is -2. Okay, so and then the BA, the vector BA, which is the component of B parallel to A, I think should be -2 A. Tak apa, nanti saya check balik. So we get 8 minus 2 0. Okay, but I will check. Okay, macam tu konsep dia. But later I will check and give you the right answer. Jawapan dia tak tahu dari mana soalan ni dapat dah. So basically to find component of B parallel to A, you can draw something like this. And then the component B parallel to A is basically this vector. Okay, macam project kan dia. So similar to this concept. Okay, so you can use dot product. Okay. Okay, any question? Okay, if you don't understand, stop je. Okay. Okay, so another multiplication of vectors is called the cross product. Okay, so let's say if you have vectors u and v that has angle theta between them, so the cross product of u and v can be the formula is written as this one. So u cross v, the magnitude, equals magnitude u times magnitude v sine theta. So cross product will produce a new vector that is perpendicular to both of the vectors. So let's say if you have vector a vector u and v, so you want to find the cross product. So the cross product is perpendicular to both of this vector. Okay, so this is the cross product. Guna right hand rules kot, okay, to find the direction. So the formula is only to find the magnitude. Okay, so formula ni untuk cari magnitude saja. So to find the vector u cross v, kalau masih ingat di sekolah menengah, kita boleh guna determinant. Okay. So this is some of the properties. So u cross v, kalau kita terbalikkan v cross u, so you cannot simply terbalikkan. Okay. So you must add negative. So when you terbalikkan cross, so it becomes a negative direction. Okay, number 2 ni abaikan. So if you have a constant, so the constant can be factorized. Okay, so rules yang number 3 here, number 3. So if you have u dot v cross w, so you can, if you have this form u dot v cross w, so you can rearrange the order. So it becomes v dot w cross u or w dot u cross v. So this is only apply for perpendicular vector. Okay. What I mean is that, let's say if we have vector e, let's say e1, e2 and e3, so dia punya urutan mesti you must make sure that the order is the order of the vectors are always perpendicular, macam cakap tak faham kot. Okay, so u dot v cross w, so if you write v, so dia mesti followed by w and then u. So if you start with w, then it must follow by w and then v. So dia punya sequence or urutan dia u v w. So you tak boleh tulis u dot w cross v because selepas u is always v. Okay, so this w cross v dia akan jadi negatif lah kat depan. Okay, so make sure you look at the order. Okay, so u v and then w. So if you start with v, then v w and then u. Okay, faham kot. And then if you have u cross v plus w, so you can cross to each of the vectors separately. Okay, u cross v or plus u cross w. Okay, boleh kembangkan dengan syarat dia plus or minus. Okay, so kalau dalam ni dot product or cross product, tak boleh kembangkan. Okay, so cross product characterize the area of a parallelogram. So let's say you have two vectors u and v, and then the cross product is the vector perpendicular to u and v. Okay? Nah, macam dalam gambar ni, dia perpendicular. So the magnitude of the cross product is equals the area of parallelogram u and v, macam dalam gambar ni. So the right-handed cross product u and v or u cross v is always perpendicular to the vector u and v. Okay, so if you write V cross U, then it becomes negatif ke bawah lah. Okay. So konsep ni kena faham lah keluar exam. Cari area of parallelogram for two vectors U and V, for example. So the area equals the magnitude of the cross product. Okay. So area of this square or the rectangle here, quadrilateral here, segi empat ni is the magnitude of the cross product. Okay. Okay, so before we can do cross product, kita kena tahu satu lagi simbol. So we call this Levi-Civita symbol. Okay, macam carut yang bunyi dia. So in order to express the cross product in terms of components, we introduce the permutation or alternating or Levi-Civita symbol. So EIJK equals 1 bila the permutation tadi IJK are even. Okay, so now similar to the one I explained U, V and W, so it's called the permutation, okay? Ataupun dia punya order dia. So let's say if you have 1 2 3 2 3 1 or 3 1 2, so this order are even order, okay? Or even permutation. So the Levi-Civita symbol for even permutation equals 1. So let's say if you have the permutation yang tak even, like 1 3 2 or 2 1 3 or 3 2 1, so it becomes an odd permutation. So it equals -1. So if there is a repeated index, so it becomes 0. Okay, so these are some of the rules. Kita akan tengok ni lebih detail nanti, okay. So for now kita fahamkan dulu apa benda lah ni, okay. Masya Allah. Okay, so yeah. So let's look at the cross product first, okay. What is cross product? Ada example? Tak ada. Okay, so let's say we want to find a cross product. Let's say U equals kita ambil soalan tadi lah. Tak pun guna simbol je lah. U1 E1 plus U2 E2 plus U3 E3, and then we have V equals V1 E1 . So if you want to find V U cross V, so you can use the determinant, okay? Determinant concept. So dulu kita belajar I, J, K, and then kita letak U1 sini, U2, U3, V1, V2, and V3. And then kita cari determinant dia. So determinant. So I equals U2 V3 minus U3 V2 plus yang J pula. So J times so yang tengah ni dia minus. Okay, so determinant ni patutnya korang lebih tahulah sebab saya dah lama tak pakai, tak kira manual. So we have U1 V3 minus U2 V1 and then plus K U1 V2 minus U2 V1. Okay. So this is how you find cross product punya vector. So the formula that I shown earlier is to find the magnitude. Okay, so after you find the vector, you can find the magnitude or simply use the sign formula. Okay. So this is how you find the cross product punya vector. So here you use determinant. So in the determinant, we have like U2, V3, U3, V2, and so on. So to write this in a compact form, yang lagi simple form, secara matematik lah, okay. Entah kenapa diorang buat, mungkin diorang rasa lagi senang. So we have to use this Levi-Civita symbol. Okay, so in Levi-Civita symbol, let's say if you have E1 cross E2, so because the permutation is even 1 dengan 2, so it's equals E3, okay. Dia punya perpendicular of E1 and E2 is the E3 vector. So if you have E2 cross E1, so permutation dia odd sebab start dengan 2 dulu followed by 1. So you get E3 but minus, okay, because minus 1 here for odd permutation. So similarly, E2 cross E3, so this is even permutation, 2 and then followed by 3, 2 followed by 3. So you get E1. So if you have E3 cross E1, so this is also even permutation. So you get E2. So for odd permutation, E3 cross E2, so 3 sepatutnya followed by 1, but this time it follows by number 2. So you get negative E1. So similarly, E1 cross E3, so sepatutnya E1 cross E2, tapi it crosses E3, so it becomes negative E2. So if we have a similar symbol, similar number or index, E1 cross E1, you get 0. So similarly, E2 cross E2, 0, E3 cross E3, 0. So maksudnya kalau dua vektor yang parallel, yang selari, we want to find the cross product between two parallel vector, so it becomes 0. Okay, so cross product is only for vector yang ada angle between each other. Okay, so we can write EI cross EJ using this symbol epsilon IJK times EK. Inilah dia Levi-Civita symbol. Dia compactkan all of this operation into a symbol tu je. Tapi tak ada function pun symbol ni. This is just to make your handwriting lebih tidy lah, tu je lah. Tapi dia punya rules nak kira panjang sebenarnya. This is just to make your handwriting nak jimat ruang kertas. Tapi kita tak guna ni dalam calculation. This is just introduced to you so that later when suddenly encounter this kind of thing, macam pernah tengok tapi tak faham pun. Okay, macam tu. Jangan risau, tak boleh exam. Okay, so to find the Levi-Civita symbol, we use the determinant. Okay, so as I said earlier, to find the cross product, we can use the determinant. Okay, so jangan tanya ni apa. So we have introduced the symbol square bracket. Okay, tu tahu apa? The product of the permutation symbol. Okay, so kita abaikan ni dulu sebab this is too much already. Okay, so obtain the coordinate expression U cross V. Okay, so this is what I've shown earlier. Okay, so how to find the cross product. So if you write in index notation form, dia macam satu barisan je, tak ada determinant. Tapi nak cari ni, in the end you have to use the determinant jugalah in the end. Okay, so to find the cross product U cross V, you can just use determinant of this, okay, that I shown earlier. Okay, so for now kita lupakan simbol ni. So to find the cross product, determinant of this thing. Okay, another example. So this is the application of cross product. So just now the magnitude of cross product, let's say let's say we have W equals U cross V. So magnitude W or magnitude U cross V is area of parallelogram. Okay, area of the parallelogram made by U and V. So now I'm going to introduce you to a triple scalar product. So triple scalar product is when you have U cross V dot W. Okay, you have three vectors. Now you cross U and V and then dot W. So for example here, you have U, vector V, and vector W. So you cross U and V and then dot dengan W. So when we do this, we are actually calculating the volume of this a box, okay? Box made by U, V, and W. So we call this box as a parallel pipe. Sebab dia taklah box sangat, dia macam parallelogram, means it's a bit sengit, okay? So to find the volume of this parallelogram, so the volume is U cross V dot W. Ini penting untuk exam. So let's say if I give you three vector, then find the volume of the parallel pipe made by the three vectors. So you just use U cross V dot W. Okay, ni dia punya derivation lah. Okay, so derivation ni kalau minat bolehlah fahamkan, tapi tak minat. Okay, so to find the volume, you just cross U and V dot W, or you can cross V cross W dot U, or W cross U dot V, but make sure the permutation even permutation. Okay, so this is the permutation lah, U, V, and then W. Kalau V dulu, V, W, and then U. Kalau W dulu, W, U, and then V. Okay, so make sure you follow the even permutation. Okay, so this exercise is about index notation. So kita abaikan dulu exercise ni. Okay, so that's it for vector. That's it for today's lecture. So you can try do exercise dalam buku, dalam kalam saya ada post some books, or you can also try do exercise dalam midterm exam sample midterm exam. You can try the first question. That one is related to vector. Okay, any question before we end this lecture? Okay, so regarding class on Tuesday, kelas tu macam 1 jam, lepas tu start pukul 8, so macam tidur. So what I want you to do, if you wake up early at 8, so can you try do MATLAB tutorial that I posted in Kalam. Try explore MATLAB. I think you already used MATLAB before, so I think I don't have to teach you more about MATLAB, like how to use addition of vectors in MATLAB. I think that one is simple, but maybe a more difficult one, like how to use how to integrate or differentiate a function dalam MATLAB, for example. That one I will show you maybe starting week 5 ke week 6. Okay, so maybe for now, if you are asking what happened to class on Tuesday, so you can try do the tutorial first on your own, and then later maybe week 6 ke, I will go into detail how to use MATLAB, like in plotting ke, or in using symbolic MATLAB. So symbolic MATLAB, basically you can differentiate a function similar to symbol lab lah. Okay, sama macam symbol lab dalam Google. Okay, so for now just try on your own. I'm so sorry sebab kelas Selasa tu macam tak apa hal dah letak pukul 8. Okay, any question before we end this lecture? Okay, so if you have no question, that's it for today's lecture. And next week we are going to look at how to more about matrix. Okay, so we learn about vector. So next week we are going to learn about matrix and or tensor. Okay, so that's it for today's class. Thank you very much. Assalamualaikum and goodbye.
Waalaikumsalam. Thank you, sir.
Waalaikumsalam.
Thank you.
Thank you.
Thank you.